Hey guys, welcome to episode 4 of Coding Every Day until Codeforces GM. Yesterday, contest kind of shat on me. Wasn't able to do two problems, just got problem 1 and really struggled with problem 2. I did actually attempt problem 3 afterwards, but I thought I could do it. Like I was really close, but I ended up misreading the question and I had like 20 minutes left on the clock. Um, so today, I guess what we're gonna do is we're gonna start up with this 900 rated problem that I was working on as like warm up yesterday. I'd never finished it. So we're gonna finish up this one today, and then we're gonna go back and work on B because I went through like the solution to this problem with my competitive coding friends, and I think I have a general idea of how it should go. It's actually like it's not as difficult as I made it out to be. Like this was just straight up brute force, and it works for brute force, which is cool, but it's too slow. It's like O to the n cubed when the actual solution could be O to the n. And then we'll look at problem C. It like almost works. I'm pretty sure we can get it this time. And if we have any other time, maybe we can end with some 800 rated problems. It depends on how I'm feeling though. I am a little busy today. But without further ado, let's get started. So, even and odds. Basically what this question is saying is this guy, Voldia, hates how numbers are ordered, and he basically wants to take all the even numbers and move them to the end of all the odd numbers. And then we have to print the number and the position k after that manipulation. So for example, this first one here, instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's 1, 2, 3, 4, 5, or it's 1, 3, 5, 7, 9, and then 2, 4, 6, 8, 10. And then we want to print out the one in position 3. 1, 2, 3. So that's how we get 5 here. So I started out with some like simple, like this is my intuition. We basically start off finding like where the evens start, and so check even, and then even index start is basically just the number of numbers, the length, I guess, divided by 2. And if it's odd, it's divided by 2 plus 1. You can check that this works. So for 10, it'd just be 5. So 1, 2, 3, 4, 5. And then even starts at 6. Well, I mean, technically it starts at 0, so right? So 0, 1, 2, 3, 4, 5. And then for odd, like we can try with 7 here. Let's just ignore that this 9 and 10 and 8 is here. It'd be 3 plus 1, so 4. 0, 1, 2, 3. Uh, 4. Wait a second. Is this right? N double divide by 2 plus 1. Even start. Yeah, it is. 0, 1, 2, 3, 4. Yeah, I don't know. I got confused for a sec. But yeah, it seems like this is working, at least this part. And then my thinking was if k is less than even start, just print k times 2 minus 1. So this should get the odd number out. Else print k times 2 minus n, which is n's the length. So ideally it would just pop you out the even number. But I'm pretty sure something is messed up along the lines here. Like the logic seems sound to me, but Oh, I don't think it's completely right. But I guess our goal today for this problem is just to figure out what's going on with this part. Um, so I guess we can always take a look at it. Let's check cases with this. So if k is less than even start, then k will be odd. This guarantees an odd because it's k times 2 minus 1. Now we can check with just some odd values, I guess. I guess there's two technical cases. Let me pull out my whiteboard. There's case when case 1 k is odd, n is odd. Case 2, k is even, n is even. Case 3, k is odd, n is even. Case 4, k is even, n is odd. So we want to check through all 4 of these cases and see if this behavior holds true. If it does, then it's correct, else something wrong is going wrong. And I know something is going wrong, but I guess pinpointing which case is wrong would help a lot. So we can use this 10 array for cases even, I guess. K is even, n is even. So I guess let's use k equals 1, 2, 3, 4, 5, 6, 7. We're going to do k equals 7. Or, yeah. Well, I guess as in k is even, I don't mean the index, I mean the output, the actual value of k. So it would be 1, 2, 3, 4, 5, 6, 7. That's 4. But so the correct answer should be 4. And using my formula, I should get 7 times 2 minus n, which is n is 10, which is 4. So this seems correct. Case 2 seems correct. For k is odd, we can pick something like k equals 3. 7 times 3 minus 1 is, or 7 times 2 minus 1 is, or what 7? 3 times 2, so k times 2 minus 1 is 6, minus 1 is 5, and then 1, 2, 3. Yep, this case seems to be working. Now, case 1, k is odd and n is odd. So let's get an odd array. I don't know why I listed 2 of these. But yeah, we can use the 7 array that was created earlier. But we can do k is odd and n is odd, so k equals 3. Be 7 times 2 minus 1, 7, or 3 times 2 minus 1 is equal to 6, 5. And then 1, 2, 3. That seems right. And then case 4 is k is even and is odd. So we can do k equals 5, I guess. And then it should be 2 here. 5 times 2 minus n is 7. It's equal to 3. So this is wrong. So we're getting 10 minus n is 3, which is 1, 2, 3. It's 5 when it should be 2. Okay. So why does this mess up? First of all, 7 divided by 2 is 3, not 4. It seems when n is even, okay, let's check if n is even and k is right on like the cusp. So 9. I guess that's 1, 2, 3, 4, 5. K is 5. K equals 5. We would get 5 times 2 minus 1, which equals to 9. Okay, that works. So it's literally just this case 4 with odds. Or I guess we can just check odd, odd, but it's right on the cusp. So that would be k equals 4. 8, 7. Nope, that works too. So yeah, it's literally just this case 4. K is even and n is odd. So I guess it's just special case when it's odd, because 7 can't, when an odd number is divided like this, it takes the floor. 3 plus 1 is 4. 7, 3 plus 1 is 4. 1, 2, 3, 4. Okay, but 11, 5, 6. One, 2, 3, 4, 5, 6. Should be 7. Okay, so odd logic is just wrong here, I think. It should actually be plus 2. Oh. It should be seal plus 1, it seems like. To get the even start index for an odd. Because it just doesn't matter whenever it's even, whenever it's odd. Yeah, I did less than, not less than, equal to. Okay, this should be right, because 7 divided by 2 now is 3, plus 2 is 5. 11 divided by 2 is 5, plus 2 is 7. 1, 2, 3, 4, 5, 6, 7. Okay. Five, 7. Let's just test. 6, 11, 16. 6, 11, 16. 9, 11. Wait, 6, 11. I'm supposed to be testing 11, 6. Why does this end up with 16 though? When n is 6, k is 11. K has to be less than n. It's just a default case. Well, that's funny. My code doesn't actually check for that. But it shouldn't actually give us a case where that matters. But yeah. 1, 2, 3, 4, 5, 6 makes sense. And then we can check 7. It should give us 2. 3. Why does it give us 3? 11. Okay, 7 times 2 is 14. Minus 11 is 3, in fact. 1, 2, 3, 4, 5, 6, 7. What did we get for the 7, 7? We got 7, 7. There should be 6. These are both higher by 1. Is this minus 1? Minus n minus 1. Even minus odd will give you an odd. Right. So minus 1 would make sense. Eleven, 7, 2. That's right. Yeah, I don't know why this just passed my head. This was supposed to print 6, but it printed 7. 7, 7, 6. Okay. Okay. Seems to be working now. Submit it. Even odd. Wrong answer, test 5. Eight, 5. Jury answer is 2. I outputted 1, 8, 5. 1, 2, 3, 4, 5. It should be 2. It's even. 5 times 2 is 10. Oh, it's greater than index, so it should be here. 5 times 2 is 10, minus 8. 10 minus 8 is 2, minus 1 is 1. It should be 2. Okay, so is there a case? I guess there's an extra case here where it's like, if this print this else this. Okay, but I thought I checked this case. Is even and n, when n is even, k is even. Even. Thought I checked this case. Case 7, 10. When n is 10, k is 7, 4. What's different from these two cases? Mm, 10 divided by 2 plus 1. 8 divided by 2 plus 1. That's correct. 10 times, or 7. Oh, I guess what's different is the index is even or not, or odd. I guess that would matter too, because that would matter if you minus 1 or not. But then do we need to check for this one? Well, this will always be even. Minus 1 will be odd. Whereas for this one, it could be even minus even, it could be even minus odd. So no, that's why we don't have to check for this. I think this is right now. Just resubmit. The worst part about this site is how slow it is sometimes. Wrong answer, test 7. Jesus. I wasn't expecting this question to be so rough. Seemed like an easy enough question. Eat 4. My output is 0. Jury's is 7. When do you output 0 in this question? That's not right. So 8, 4, 1, 2, 3, 4 should be 7. K times, so this is less than even start index. K times 2 is 8 minus 1. That's 7. How are we getting to 0? Are we getting over here? So we're going in here. Else. What's our even start index? It should be 8 mod 2, it's even. So our start index should be 4. Wait, it should be 5. On 2. Like 10. 5 by 2. 1, 2, 3, 4, 5. Should be 6. Should I be adding 1 here? Wait, how am I getting so confused? Jesus. Am I just stupid? Bad day, I guess. Woke up late. 8, 4, 7. That's right. That didn't mess up any of the earlier ones, right? Sweet. Test 10, 7 to be 4. Yeah, okay. I guess I just could not find the edge cases for the love of God today. There we go. Wow. Took way longer than expected. 27 minutes to fix a problem that I already started. Jeez. I'm so crusty. Okay. Now let's go to yet another MEX problem. I guess I can just go to my submissions. Problems? No. Wait, do I have to go to my account? I don't really want to go to my account because my email's on there. I don't want to leak everything. So I will pull it up on my alternate monitor. Actually, I have the link in here. Like, what am I saying? You know, I will pull up my account just because we did a contest and we have a rating now, which is pretty cool. I will just like right click and inspect my email away. What should I put here? Okay. Would you look at that, guys? We are 409 rated. I feel like we could have done better. We could have solved problem 1 faster, I think. If I found out the gimmick faster, and I did 2 submissions that failed for B and C. I think we could have gotten at least C. I shouldn't have gave up on like after B. Like my mind was just so boomed, morale was low. But whatever. We learn from mistakes and we move on. Because I was like, if I couldn't solve B, like C would have to be impossible, you know. Like, but that just wasn't the case. Okay. Now let's pull up the next question. Yet another mechs problem. I'm back for revenge. So we can start by commenting this all out. And what can we keep from my code? We can keep the input, I guess. What happened? Control C, Control V, uncomment. So, I guess what the most important piece of this question that I did not pay attention to was that if you watched the video yesterday, I added this loop kind of halfway through building the solution because I didn't really realize, or I didn't really read this line of code or this line of the question. But we only want to run it for this many operations, and after that many operations, our array length is k minus 1. We're left with an array of k minus 1. So what we can do is we actually don't really care what we remove from the indices. We don't really care what we drop, because no matter what, we're going to end up with k minus 1. So all we have to do is find the max of the last array. What we can do is we can have a counter array. I guess counter equals 0 times n plus 1. We do n plus 1 because n could be in the array, right? It's a 3 length array. It could be 0, 1, or it could be 3 in there. And then we need a loop through this we basically need to count up all the things. Kind of what I did in this drop function, we're not exactly looking for duplicates. Here we're just fishing out. We're creating a loop we can iterate through to find the max. So for blank and oh yeah, when I was talking to my friend earlier, he likes using this blank symbol for iterations. So they'll never run into conflict. For example, I should use blank here just because it's literally just here to iterate through test cases, and I can save variable I for something else. So it's something to keep in mind. I'll use this blank symbol more often, which is not something I'm used to. I've never really used it before. But for I in A, or for blank in A, we would count. Let's not name it counter. Let's just name it count, because it's the count of all the variables. Count blank plus equals 1. We should also define a max. At the top, and then we can iterate through this count. We can iterate through the array, the final array. So k minus 1 is the size of the final array. And what we basically do is if underscore not in count, then max equals not in count. We can just check the current index of count, because If we check not in count, we're checking the entire array every time. This, like this, we're just checking if this indice exists or not. Well, it would exist, but as a 0. So yeah, okay. We would set max to be our index, and then we'd break. And then we would print max. And there is one case, if not count. Okay, if we're just checking if this exists or not, we don't need this here. It's just if not count. Right, I think so. Okay, and then we would print max. There's one case we don't handle, which is when max is not 0. We're setting max to be 0 by default, which is not good. We should set this to like -1 because it can never be -1. And then if max is equal to -1, max would equal to k minus 1. So that's just saying if we iterate through and we hit everything, then max never changes here. So we would need to change it to the length of the array. So like I guess it's kind of hard to explain, but it would make more sense if we just ran through an example. Let's see this 7, 5, 0, 1, 2, 4, 0, 3, 1, 1. So first, we would count up all the things. So 0 would be 2, 1 would be 2, 2 would be 1, 3 would be 1, 4 would be 1. That's this array. It's just 2, 2, 1, 1, 1. And we have the indexes from 0 through 4. Right? And then 4 underscore in range k minus 1. So that's our end array size. K minus 1 is 4. If not count, so we would check from 0, 1, 2, 3, 4. I guess we can just input and then print. Let's do this. And then like this. Clear. Do one case. 7, 5. Okay. So this is the count array that we just talked about. Let's count. Right? So we initialize it to a size n. n is the length of the array. But yeah, so we're iterating through count 2, 2, 1, 1, 1, and then since we never update mex, like we never get into this not count, we go through the entire k minus 1. K minus 1 is 4. So 1, 2, 3, 4, or 0, 1, 2, 3, 4. And we hit a value for each of these. Then we never update mex, and we have to update it here as k minus 1, which is 4, because k is 5. Now, let's show y'all one where it does go through here, and I think this one would do just fine. 1, 6, 2. Okay, yeah. So this is our array. We just count up the instances. 0, 0, 0 shows up 3 times, 1 shows up 2 times, 2 shows up 1 time, and everything else shows up 0 times. So k minus 1, our k is 2. 2 minus 1 is 1. So 0, 1, and wait, 0, 1, that's our window size, and we never update, so k minus 1 is 1. Wait, this isn't a good example. Where's one where... Okay, let's just dump all of these in here, and we'll find one. Okay, here. Very first one, I guess. Count it all up. 0, there's 3 zeros, 0, 1, 0, 2, 0, 3s, and then our first pass, 3 zeros. Okay, k minus 1 is 2, so go through this. 0, 1, 2, 0, 1, 2 doesn't exist, so by default, our mex is, or 0, 1, since it's 0, we print out not count, then it's 1. Because it's not that 2 doesn't exist, it's that 1 doesn't exist either. There's 0 instances of 1. So, yeah, I guess it's the only one in here that's like that, but that's basically how it works. A little bit confusing. I guess summary, we count it all up in here. If it's equal to 0, then we set it to the max, iterating through k minus 1 if underscore is ever equal to 0. If count underscore is ever equal to 0, we set that equal to the max. We can do this because our end array is length k minus 1. And then if it's never updated, then k is just the length of, then max is just the length of the end array. And then we'd print it all out. So this should work now. Let's delete my old code. Save. Submit. Yet another max problem. Wrong answer, test 1. Jeez. I have an extra print statement here. My bad. There we go. See? So much shorter than the code I had earlier. Like, what was this? 80 minus 29. 80 minus 30, basically 50 lines of code. But okay. Let's move on to war strategy, I guess. Okay, so I actually kind of misread this problem when doing it, but basically what it's asking is, so every night you can move all the soldiers. So okay, so you're given 3 inputs, N, M, and K. N is the number of bases in a line. K is the index of your home base, and then M is the the number of days you have to fortify your base before your bases before the enemy's attack. And it's considered fortified if at least 1 soldier is in the base. You're ordered, yeah, I already said this, but you're allowed to move all the soldiers inside of 1 base once, left or right, every night. You cannot move soldiers past like index, like the first base or the nth base. And every night, a new soldier moves into the initial base, where that soldier cannot be ordered by that night. So we can look through an example. So day 1, we start with the soldier in our home base, our initial, and then day 1 we can move him, and a new soldier spawns in our base. And then day 2, we move all the soldiers in this one over 1. Alright, and then I don't know why they did like this, but it is like this. So move over 1 and then a new soldier spawns in this base. And then we end up with something like this. And then now it's kind of weird because if you were to this is 3rd test case. I'm assuming they give us 3 days. But if there was a 4th day, here's where the struggle comes. Since we can only move 1 base once per day, we would move this guy over to fill this space. But then we would have 2 in this one and this one not filled. So if we had another day, theoretically, we're going to move these 2 soldiers here and fill all the bases. But that's slow, right? So what I have going on right now is I track the left base, then the leftmost base, and the rightmost base. And so the leftmost base is just going to be our index base minus 1. And then our rightmost base is the number of bases minus my index base. So this is just like the number of bases from my initial base. And then we check if M, so the number of days, is less than or equal to the maximum of left or right. So if it is, then basically the strategy that I came up with is that you would just, so let's say it's 2 on this example here. That's less than or equal to right? So that's 2 equals to 2. So our strategy would just be to every night shove a soldier over, and we can fortify 3 bases, right? Because day 1 shove, day 2 uh, shove. Wait, hold on, let me just double check. Yeah, yeah, yeah. Um, yeah. And then at day 1 shove, it spawns 1. Day 2 shove, spawns 1. And then you would have 3 bases maximized. But that wasn't really the case I was trying to explain. But yeah, this was, I guess, the mistake in my logic when I was doing it. Um, like what I thought is I thought you can move any number of bases in one direction, but so that's what this code does. It allows you to move any number. So like, say I had like this, I thought I could move bang bang here, here in one night, and that's just not the case. So let's delete all this. What is the way to do it here? Um, let's think. So we're allowed to move one base once. We want to move, I do it every night, or we'll have duplicates, and duplicates are bad. So this third test case here, we have 4 bases. Starting point is 2, and we have 2 nights. So night 1, move either direction. Spawns 1 in. Night 2, move in the opposite direction. Spawns 1 in. Let's say we had another night. What would be the optimal thing to do? I think like this is optimal first play no matter what, right? Because you feel 3, and then basically as you expand outwards, you have to give up a day filling up 0 bases. So let's just look at a case where we had like an infinite amount of, so this is our starting base, and these are our other bases. Let's just look at a case where we had like an ample amount of bases and materials and days, I guess. So day 1, we start here. We move and we end like this. Day 2, this guy is still here. We move on over here. We end like this. Day 3, we would have to like do either of these, right? If we did this, we would have this. And we would end the day like this. So initial day 1, day 2, day 3, day 4. Like this. Day 5. We have to waste another day to fill a new base. So the important part here is to look at these. Basically, after day 3, to fill a new base, it takes 2 days. Okay. Let's do that. If m is less than day 1, day 2, no, it's after day 2. Alright, because day 1, day 2. If m is less than or equal to 2, print in, just number. Wait, if just track bases. Right? So if we had 1 day, if we had 2 days. Okay. Now, else bases would equal to so there's multiple problems. And the problems are the edges. What happens when we hit an edge? Let's say we deleted this one and we're at an edge. Or no, let's bring that one back. No. We don't even need that one. Because we're at an edge. Then we would have to expand the other way. So bases would equal to 2 plus m no, it would be m mod 2 Okay, so let's look through this. If it's even, it's -1. Okay, we're at 3. 3, 4, 4, 5, 5. Be subtracted. Oh, what would so basically it's um so now we need to relate these series somehow. What is a series? A series is I equals 2 to infinity. That's the worst infinity I've ever drew. Sum. Why am I doing the sum? That's not it. This is 4 I equals 2 I equals infinity I plus plus. And then if I mod 2 equals 0, x is 0, 1, 2. Start this from 1, or start this from 0. If is 0 count plus plus 3 0 1 odd count does nothing 0 1 2 plus 1. Okay, so instead of just writing it, I can actually just code it. So I have VS Code open. The range would be number of days or the number of bases. If minus m. Okay, there's some condition where like the range here would be n or m based on some math, but I don't know yet, so I'm just gonna say let's do it. Let's say we have infinite bases for now. For I in range m, if so this should track the number of bases full based on the number of bases is full as long as m is greater than 2 and we have an infinite number of bases, right? Now we don't have an infinite number of bases. So I guess this is the hard part. This will go here, but we have an if statement. Let's do this, and then we can call this counter equals if the number of bases m, or if the number of bases n if the number of days m is less than number of bases, counter equals m, else counter's in. Is it just this simple? How many bases do we have here? Let's erase all this. Okay, say we had 4 bases and we had 6 days. And counter would be based on bases. Right, which would equal to 5. We had 5 days, counter would be we had 7 days, it'd still be 5. Oh wait, don't we always just use m, but cap it at 7? So instead of doing this BS, we can do if and this is less than n, else, wait, something like that. Oh, else, that should be it. Two, three, three, 2, 3, 6. 2, 3, 3, 3, 4, 6. So that's not right. 2, 3, 3, 2. Oh wait. 2, 3, 3, 2. 3, 2, 1 is wrong. So in my case, I have 3 bases. I'm at position 1. Your bases position 1. 2 days. We have 2 days. So day 1. Day 2. Day 3. Okay, wait, so this is a problem. If the thing is on the edge, we can't default it like this. Um, bases. What is this saying? Start at index 0. If m is less than 2. Oh, someone is at the door. I'll be right back.